How are memories formed, rehearsed, and retrieved? How do the aspects of memory interact with and complement one another? One model that has been proposed to answer these questions is the Atkinson Shiffron model. Think about going for a nature walk. During that walk, you're constantly retrieving a stream of sensory input in your sensory memory. That Atkinson Shiffron model for memory starts with all the sensory information from your environment being received and coming into your sensory memory. In order to retain information in your sensory memory, you need to pay attention to it. Thus, information is filtered and selected from your sensory memory into your short-term memory by your attention. Not to confuse yourself, short-term memory is often interchangeable, referring to as working memory. Information within your sensory memory that you do not pay attention to is lost. Let's come back to our nature walk. You would not remember every moment of the walk in all aspects of the trail that you saw and heard. This is because the majority of the sensory input into your sensory memory is lost because you don't pay attention to it. However, the specific sensory input that you pay attention to that we passed into your short-term memory. For example, let's say you love flowers and you notice a beautiful yellow wildflower when you start walking. This will be passed into your short-term memory. Once in your short-term memory, information is further filtered and selected depending on how much you rehearse and thus maintain that memory information. At this point, that which is not rehearsed will be lost. Think back again to the nature of what. Imagine around the next turn, you see an even more beautiful purple flower. Now, as you continue your walk, you're thinking of the more beautiful purple flower and no longer the yellow flower. You are rehearsing and maintaining the memory of the purple flower while the memory of the yellow flower may be lost due to your lack of rehearsal. Finally, if the information in your short-term working memory is encoded, then it can be stored in your long-term memory. Once this information is stored, it may be retrieved and brought back into your short-term memory at a later point in time. Again, back to our nature walk example. You likely will not continuously think about the purple flower for the rest of the day. It may leave your short-term memory, but later that evening, if someone asks you about your nature walk, you might easily retrieve that memory of the purple flower from your long-term memory. However, if you are asked about the walk in 10 years, it is possible that you wouldn't recall anything about the purple flower or potentially even the walk. This is because some information is lost over time from your long-term memory. If we take a bit of a closer look at each of the three memory stages, we can see that each stage has a unique information, capacity, and retention duration. First, sensory memory has a large capacity in a very short duration, usually seconds or less. Think about all the stimuli coming in from the environment at any given time. Second, short-term memory has both a small capacity as well as a relatively short duration. Remember this, that the memory stage that allows you to think about the present sensory information and work on problems in the immediate moment. Working memory may last for 18 to 20 seconds. Finally, long-term memory has both a huge capacity and a very long duration. In fact, there are no known limits to long-term memory in certain memories that last for entirely a person's life. The Atkinson Shiffron model represents a way to interpret how our memories are formed, worked on, and later retrieved. While it is important to understand that this model is a working hypothesis, it provides a strong rubric for how we might interpret.